This is Divyasri from Triple Department, second BTech and first semester. This is my CA2 assignment. My topic is separation of losses in transformers. Subject name is DC missions and the transformers. Introduction: a transformer is a static device that can handle the frictional losses absent in it and mechanical losses present in it. The losses in transformer can divide into two types: iron losses and copper losses. The iron losses are again divided into two types: hysteresis losses and the the hysteresis losses and eddy current losses. Eddy current losses in a transformer. Eddy current magnitude can be reduced by designing the core as a set of thin sheets or laminations in parallel to the magnetic field. Each Each sheet must be insulated from its neighbor within a coating or vanishing or outside. By laminating the core, the area of cross section and hence the induced EMF is reduced by adding 3 to 5% of silicon. And the eddy current magnet and the, will increase the resistance of core. So induced eddy current will be more than 5% and it will make the core brittle. Hysteresis losses. Hysteresis loss is a type of energy loss that occurs in a transformer when the magnetic core becomes saturated. This happens when the core is exposed to a strong magnetic field like that one generated by an AC current. In hysteresis losses, the hysteresis losses mainly occurs due to the reversal of transformer core. Every magnetic material has some amount domains or small magnetic parts plus, like the plus or minus poles in it. The normal condition, the domains remains or arbitrary position, but when the subjected by a magnetic field, hence the domains come parallel with the magnetic lines. Now the transformers some are running with an alternating current of reversal of every cycle. So the domain changes and the position. So, due to the frequency increasing, some work done will be there. By the work done, for the reason some amount of electrical energy was wasted. Hence, the amount of wasted, the electrical energy was wasted. The wasted energy is known as the hysteresis losses. In separation of losses test, Eg equals to P pi by Nz by 60A. By this, we can write the Eg is directly proportional to N. If Eg increases, N decreases. If N decreases, the frequency decreases. By this, the total losses equals to hysteresis losses plus eddy current losses. AF plus BF square. By this diagram, we can write the AF plus BF square. In the losses of transformer, the core losses and iron losses are constant losses. In this copper losses or in a transformer, copper losses in a transformer or copper losses is due to the ohmic resistance of the transformer and the copper losses equals to primary copper losses plus secondary copper losses. Windings of the copper losses to a transformer wires to the lead. By this graph, we can write the AF plus BF square. And if we conducted any experiment, due to the separation of losses state, the separation of hysteresis losses and eddy current losses, the tabular column must be the voltage, speed, Pi, and the Eg. Voltage, speed, Pi, frequency, and this is the Eg. if the terminal voltage increases, if in case it is 1500. The frequency also, the speed will decrease. It will must be 50, or the voltage must be 230, and the speed will decrease and the pi will increase and the frequency also decrease. By this we can understand that the separation of losses state, the Eg increases, the frequency decreases, and the pi increases and the speed decreases. By Eg increases, speed decreases. If the speed decreases, automatically frequency also decreases. If the frequency decreases, the pi will increases. This is about the separation of losses test in a transformer. Thank you.